This video will be about optimistic updates, which are useful for providing the application with a feeling of snappy responsiveness by assuming server calls will be successful. To illustrate how Lore implements optimistic updates, let's walk through an example. So here we've got our application, and it just invoked an action creator to create a post. Here is an example action creator for handling this request. It expects a single parameter, being the attributes for the post we're creating, and then it instantiates a post model, which gives us an instance that knows how to communicate with the post's endpoint. We'll dive into actions in more detail in the upcoming video about the abstraction tiers that Lore uses to build the blueprints, but for now, you just need to know that this instance understands how to communicate with REST API endpoints. From there, the action then invokes the save method on the model, which causes a post request to be made to the API server. And then we dispatch an action, shown on the right, to notify our application that the post is being processed. And the key callouts here are the ID, being that we don't have one yet, and the CID property, which is the client-side ID that was assigned to this post by the model that was just created. So two things just happened. First, a request went out to the API server, and the second is that an action got fired representing the data we currently have available. So let's dive into the store to see what it does with it. Recall that the way the store works is that we take the initial state in the store, and then the reducers process the action, and we end up with the final state that the application is notified about. Our initial state in this example is empty, since we haven't fetched or created any data. And our action declares that a request to create a post has just been sent out. What happens next is that both the ById and ByCId reducers look at the payload and store it in their respective key. Since the ID is still undefined, the ById state stays empty. However, since the CID exists, we can store the model by its CID, and so the payload is inserted under the C1 key by the CID reducer. At that point, our application will be notified of the state change and update, and we can show our post. But because the data doesn't really exist yet, we're going to show it faded out to let the user know we're in the process of creating their request. So here we're looking at our component, and we're comparing the post state to the payload state for creating, and then rendering our faded placeholder since the resource doesn't exist yet. So sometime later, our request comes back from the API server. Taking a look at our action creator again, here we have our API server response in the top right, and when it returns, our promise will be fulfilled. And our action creator will create and dispatch a new action. Notice that this time, it does have an ID which was assigned by the server, and we have changed the state to resolved. So once again, we dispatch the action and dive into our store. This time, our initial state contains the data declaring our query was being fetched, and our new action has the data we received back from the server, letting us know that our post was created successfully. And because the CID key is the same as the CID we already have in the store state, we know that this is the same data, and we can substitute our previous payload with the new one. Additionally, because the payload has an ID this time, we can also insert it into the state through the ById reducer. And now the application is once again notified that our state changed, and the component updates the view to reflect that the post was created on the server side. So in review, optimistic updates are important because they add a feeling of responsiveness to the application. The core challenge is properly merging the optimistic and real data together, and the approach that Lore follows is to use a client-side ID to associate the optimistic and real data.